Hello everyone. For those of you who don't know me, I'm Joe from Load Cell Systems. We've been working on a system to improve the safety of your cranes and the operators. We built a proof of concept. Let me show you how it works. Here's the hardware. We've got a small PLC here which controls the stack light. It can also shut off the uplift circuit in your system in case of an overload. Here's the receiver for the wireless load cells. Here's our HMI. This is the main screen. This is probably the only screen the operator should have access to. It shows them the weight on each hook, load cell 1, load cell 2, the sum of the load. It shows them the battery status, load cell 1 or 2. If the batteries get low, these light up. The stack light turns yellow in case of a low battery status. The load cell status, if there's an issue with one of the load cells, these will light as well, also turning on the yellow light on the stack light. To package the hardware, we're envisioning a small enclosure that could be mounted behind the cab operator. Out of the way, it would house the PLC, power supply, terminal blocks. From that enclosure, we're going to use quick disconnects, the cabling from this transmitter, which is mounted up on the bridge, line of sight from the load cell wireless transmitters. We'd have a cable with a quick disconnect going to this enclosure. From the enclosure to the HMI, another quick disconnect. So it's a modular system. So if something goes wrong with, let's say, the HMI, it's a quick fix, short downtime. The stack light could be mounted hardwired from the box, from the PLC box, to, let's say, below the cab, so it can be seen from the operator or from the factory floor. Or it could be mounted, let's say, in the middle of the bridge. If that's requested, we would need a simple wireless I/O transmitter receiver package that would go from the PLC to the stack light, but it is an option. So let's look at the settings page on the HMI here. This is where you set up the system. This is all, a prototype, so it's not finished. Things will change. But here it shows the low alarm. So this would be for slack condition. Slack condition, as it's set up now, will sound the audible alarm from the stack light and light the red light. Here we have the high alarm. So in your case, each hoist is rated at the same capacity, so we have 20,000 pounds for both, and the limit of the bridge is also 20,000 pounds. So when you exceed either a single load cell alarm or the sum, that's when it triggers the alarms. Let's go back to the home. Okay, let's look at the event log screen. What this shows you is the name of the alarm, which in this case is crane overload, time, date, and duration of the event, which it is in seconds, so it's 104 seconds for that particular event. We have the data log screen. This starts capturing data once an alarm is present. Then it records, it graphs, shows you can click anywhere it's on here, and it shows you the actual weight, load cell 1, load cell 2, and the sum. So it shows you how far they overloaded it. You can zoom in on this to get a better look at it. We've got the login screen. What this is for is there's an admin which would give access to all the pages and all the settings. So you can change the set point values, add users. Here's the crane crew. They would have access to shut the system down, put it in, disarm it, so during routine maintenance you won't be getting false alarms. One feature we could add, maybe make it easier for the crane crew to log in to the system, is a RFID fob and a reader. So basically, you select crane crew here, password. Instead of them remembering the password, forgetting it, take this, enters your password, and they log in. This might be easier than trying to remember passwords. It could also be used to log in individual operators if desired. Each one would get an RFID tag specific to them. They would put it in their username or select it from the drop-down box, scan their code, and it would log who the operator was, say during a overload condition. Okay, let's have a demonstration. Again, the set point is set at 20,000 pounds, so we'll simulate increasing the load. Stack light and the audible alarm on the stack light would be going off. You heard the audible alarm from the HMI, and it ticks every couple seconds to remind the operator there is a active alarm. They can stop it by going to event, clicking on the current event, and that silences just the audible alarm from the HMI. So if we remove the load, it goes back to normal operating condition. You may have heard my phone going off. There's two apps that notify you when there's an alarm. And when it recovers, it sends you a notification. The other app basically shows you the HMI screen. Regardless of what screen the operator's on, you have complete control over it. You can go into the data logging or events and look at it, and it doesn't disturb the operator. That can be done from your phone, a tablet, or a PC. In addition to the app's notification, or if you don't have the apps installed on your phone, we can set up our contacts, and whoever's in this list, we can send them text messages or an email notifying them of the events. Again, this is just a proof of concept. We can make changes as needed. We look forward to your feedback, any ideas. Hopefully talk to you soon. Thank you.